Hello guys, in this tutorial or video course we want to work with Hot Standby Routing Protocol known as Hsrp. Hsrp is a Cisco proprietary redundancy protocol. With Hsrp we provide a level of redundancy and failover by using two routers or layer 3 switches. Hsrp works by designate one router in standby and the other as inactive. When the active router fails by some reason, the standby router will take the control so the traffic can be forwarded with minimum downtime. Well, how it works? The devices in the LAN communicate in the network using a pseudo router or a virtual router. This means that the actual physical interface's IP address of both routers are unknown to the host. The host instead uses the Hsrp gateway to communicate to the outside, inside network, or between VLANs. Right now we have three routers. We are going to enable the Hsrp gateway between R1 and R2. The ISP router that we have in this lab, I put in place so I can reach the server from the inside LAN, from the LAN we have here, and we can make some tests to see how the traffic forward from one router and the other. Right now I have configured prior of the video sub interfaces on R1 and R2. The interface in the trunk, in the switch, are in trunking for Ethernet 0 and Ethernet 1, and I have assigned for the Ethernet 5, which is the link to the host, to place in VLAN 10, in access from VLAN 10. If I make the show IP interface brief, we can see that we have the sub interface, which is fast Ethernet 01.10. And the LAN subnet that we are working is 192.168.10.0/24. So we can have 254 hosts. The host that we have placed on the Ethernet 5 port, we need to assign the IP address statically and also the server. Let's get started with the configuration of Hsrp between R1 and R2. To configure Hsrp, we need to get into the interface that are going to participate, and in this case we are talking about sub interface. So the sub interface number is 10. For R1 is faster than 01, so we need to change that 0 for a 1. Then we apply the standby, and we need to put those routers R1 and R2 in a group number. So I'm going to use the group 10 for this lab. Now I can configure the Hsrp gateway so the host in the LAN, for example host 1, can reach the network using that gateway, that pseudo gateway, that doesn't exist physically on the interface R1 on R2. So the IP that we're going to use is 192.168.10.254. Also, to take notes, the IP of that virtual gateway must be in the same subnet. We cannot use that 192.168.20.254 because we don't have that subnet configured on the physical interfaces. So this is the command that to enable the Hsrp on R1, standby group 10, IP address for that gateway 192.168.10.254. Then I need to do the same on router 2. Interface fast Ethernet 00.10 because it's a sub interface. Standby 10, we need to place on the same group number. IP 192.168.10.254. And then we need to wait to see a couple messages back and forward that is going to generate the router to choose the election. And how the elections starts? Well, Hsrp by default has the 100 number for the priority. If we have a tie, and right now we are because the router are in the default configuration, then the router with the highest IP address is going to be the active router. So I'm going to check this by using the command show standby. And show standby show us that this router is the active, and this is, I think, a bug that the router iOS router for the Genus tree have, because if we have the same priority number, then by the by the terminology of Hsrp, the documentation from Cisco's website states that the router with the highest IP address will be the active router, and we can see that the standard router right now is the router with the highest IP address. So to remediate this, I'm going to turn off and on that interface, the F01 on R1, and I'm going to turn on that again to see what happens. Okay, let's go to find out again that. And right now we are in the state in speak, and this is a great moment to discuss the Hsrp states. So we can verify this state is standby, and this is very rare because it's not supposed to be in standby. Okay, great, yeah, we are on R2. Perfect, we got the correct statement. But let's talk about Hsrp states. Hsrp has 6 states. From the Chris Bryan Ccnp book, it states that the first state is disabled, and disable is similar to the HTTP port state. In that you won't see this state actually mentioned, but it's the official first Hsrp port state. The second is the initial. The interface enters this state when Hsrp is first enabled. Hsrp isn't actually running at this point. Then we have the listen. The routers know the virtual router's IP address, but it's not the primary or standby router. It's listening for hello packets from those routers. Then we got speak. The router is now sending hello messages and participating in the election of the primary and standby router. Then we got standby, which is the router is known a candidate to become the active router and continues to send hello packets. And finally we got the active state, which is the router is now forwarding packets to send to the group virtual IP address. So with the disable and enable that interface, we got the correct information. We got that the router 1 is the standby because it has an inferior IP address, which is 192.168.10.1 on faceted 01.10 subinterface. And the R2, this is another great command, show standby brief. The R2 on the faceted 00.10 subinterface is the active, and that's because this router has a highest IP address. It has in place on the faceted 00.10 192.168.10.2, and we need to and we can verify that using the show IP interface brief, and we can see that the interface that the IP address is highest. So let's go back to the information about the Hsrp, because we have a lot of useful information to the studies or our knowledge. So the first line we have here is the interface that is participating in the Hsrp group. We got also the group number. We got also the state of this router, which is a standby. We got also change that has been made for changes. We got the virtual IP address, which is 192.168.10.254, and we have also the MAC address for that Hsrp. But we didn't configure that. So we didn't configure because this is a predefined IP address, MAC address that Hsrp provides when we enable that protocol. So this is a standard for Hsrp. We can see this in any place in any other router, Cisco router, and we'll see the same MAC address, but the last character, which is an A, that means the group number, and it's in hexadecimal. We can see that if we are in group 10, then it's A. If we got group 11, we got B, and so forth. We got also the hello time. We got the preemption is disabled, and we are going to work with that very soon. We got also the active router IP address for the physical interface and the priority of that active router. And right now we are on standby router, so this is the physical IP address for R2. And we can see that the standby router is local and the priority of this router. Also, we got the group name, and this is by default if we don't configure that. So what happens if we want to put the R1 to be the active router? Well, we have two ways to accomplish that. One is to change the IP address for the interface that is participating on that group, which is something that we don't like to do because we're going to change our topology. And the correct way is to rise the priority number. So we're going to rise that number right now. Interface faceted 01.10. Standby, the group number, and priority, let's say 105. Great. So this is the command. What happened? Suppose that this router is going to be the active router, right? Well, sort of. And we don't see any kind of change in the state, and that's because the preemption is disabled. We need to enable the preemption to accomplish this. So to do that, we need to be in the same interface, standby 10, and preemption. With that, you can see the message that this router changed the state from standby to active. And if we go to the other router, we see that the state changed for active to speak, which is one of the states of Hsrp, and from speak to standby. And that's what we are going to expect of this, and that's great. And if we use the show standby brief, we can see that the priority is 100 for the local, and also we see the change is standby, the state of this router. But we got another issue. Let's say that R1, the interface that is connected to the ISP, has some limitation, has an issue, has a problem with that interface. And I'm going to simulate this by turn off that interface. So R1 faceted 00, and I'm going to shut down that interface. And if I shut that interface, the states, the states will not change automatically. So R1 are the active router, and it doesn't know if this interface has some kind of problems. So to remediate that, Hsrp introduced a feature it's called Hsrp tracking interface, and with that feature, we can enable the Hsrp process to monitor a particular interface. When the status of that interface changes, for example, the interface down, The Hsrp interface tracking will dynamically decrement the priority of the router. Something that we need to know is that when we're using interface tracking, the default decrement is by 10. So if we had 105 right now on R1, the show standby brief, we got the manual configuration that we write earlier. So if we use right now a tracking interface, this priority is going to down automatically by 95 if the interface that we are tracking has a problem. So I'm going again to turn on that interface fast Ethernet 00 and not shut down. And I'm going to enable that feature. And that feature needs to be enabled inside of the standby configuration. So we need to get again in the interface that are participating. In this case on R1 is the fast01.10, and then standby the root number track fast Ethernet 01 00, sorry. So we are analyzing the status of this interface. Great. Okay, so what we have, if I check the show standby brief, we see that this router is active and there's not any problem right now. The traffic is forwarding to this guy. And also, I want to make a test. I forgot to enable, or not enable, to set up the IP address statically on host 1. So let's do that. IP 192.168.10.100/24. And we need to set up the gateway, and the gateway is the virtual gateway 192.168.10.254, and it's checking for duplicate address. Done. I'm going to pin that gateway to see what happened. 192.168.10.254, and we got replies with no issues, and that's great. Also, I'm going to configure the IP address on the server side, IP 192.168.2.100/24, and the gateway is the interface for the ISP FastNet 10, and it's 192.168.2.1. I'm going to verify. Remember to verify first if everything's good between the devices you are troubleshooting. That 2.1. And we got communication so far. Okay, I'm going back to this guy, to host 1, and I'm going to pin the 192.168.2.100, which is the server IP. And we got communication, and that's because I enabled prior of the lab the EIGRP routing protocol to have communication between the networks. So great. Right now, back to the Hsrp on R1, I'm going to disable the interface fast Ethernet 00. I'm going to shut down that interface, and let's see what happened. And we got a few messages here. And one of the messages that we have here is tracking state interface fast Ethernet 00, line protocol up down, and also we have the interface is administrative down. Let's see what else we have. Show standby, show standby is good. Okay, let's see what happened. And nothing happened. This guy is the active router yet. And that's because we need to enable the preemption on the router that is going to take the control, and the router that it's going to be the active in case that something happens on R1. So conft interface fast Ethernet 00.10 standby 10 preemption. And if we go back to R1, we see that the communication and the states of F faster than F01, that's 10, going from active to speak and from speak to standby. And also we got a new message here when we use the command show standby. We see that the priority is right now 95 instead of 105 that we configured. We see that the track interface faster than 00 state down decrement by 10. And that's we're gonna, that's are the thing that we are going to expect. I'm going to enable that interface again, conf t interface faster than 00 and not shut down to see what happened. Before of that, we can verify show standby brief, and we see that because of the interface tracking for the faster than 00 was down that interface, then the active routers is R2 instead of R1, and we can verify that with the states on this guy. So I'm going to turn on that interface again, and we see tracking interface right here. Okay, tracking state interface faster than 00, like protocol down to up, and Hsrp state, and it changed from standby to active back. And that's a great feature because we can track some interface to validate that the traffic is not interrupt, and if everything's good, I'm going to be the active router until something happens on that interface. So I'm going to verify again, show standby brief, and we can see that the priority is rise again to 105 instead of 95, and that states is active. Well guys, I hope you enjoyed the video. See you in the next.